As part of a modernization project, we upgraded 11 of Fanshawe College's 66 townhouse units with the goal of maintaining or improving comfort while reducing greenhouse gas emissions. We used a mix of insulation materials, airtightness, heat pumps, and heat recovery ventilators.
Using a blower door test, we determined that these buildings had a leakage rate of 5 air changes an hour. Consider that best-in-class buildings have less than 1.5 air changes an hour, which is about 70% less.
So first things first, stop the hemorrhaging. Get the leaks under control. We knew that the insulation had to be updated. The question was, should we do this from the inside or the outside? Having the students vacate the buildings for the renovation period was not an option. We decided to use what is called an EFIS, or Exterior Finish Insulation System. This was one of the solutions that local renovators were interested in following the LEAP workshops hosted by the London Home Builders Association.
Fanshawe has a goal of reducing GHG emissions by 80% by 2050. We asked ourselves, what energy efficiency improvements do we need to make to hit this target? Here, we wanted to go net zero. For new construction and renovations, there's now a trend towards right-sizing based on proper heat loss and heat gain calculations. The methodology is laid out in CSA standard F280-12 and baked into many calculation software packages. It allows us to more accurately predict the building's heating and cooling requirements. We used software tools to run various scenarios. We were especially interested in matching heat load for various building envelope scenarios and other efficiency measures to heat pump sizing. To reduce loads, air sealing by far is the number one measure having the quickest return on investment. Number 2 was attic insulation. The third measure was upgrading the windows with high-performance, low-emissivity triple glazed units. Adding basement and wall insulation was the last measure. But by doing these 4 measures, we addressed all the economically viable options and hit the net zero energy target.
It was then relatively straightforward to remove the aluminum siding, update the vapor barriers, and apply the exterior insulation, followed by a layer of foam which gave the buildings a stucco finish. We replaced the dryer and stove vents with heat recovery ventilator units. These HRV units will remove excess humidity during the summer months, and this will provide additional ventilation and comfort to the residents.
Our right-sized system will cover a greater percentage of the heating load once envelope upgrades are completed, meaning you rely less on your backup system. Decide what efficiency upgrades you're going to prioritize, and with the end goal in mind. Then chip away methodically at the envelope upgrade measure by measure until the building matches the target. I cannot emphasize enough the importance of first doing the envelope upgrades. This will enable you to install a much smaller heat pump and backup heating system than would otherwise be needed. In the long run, this approach will require less capital, have a quicker payback, and save more energy and GHG emissions over the lifetime of the system.
The hard work paid off. Fanshawe College was able to achieve a 70% energy and greenhouse gas reduction at this student resident.